So we will get back into how Filecoin connects to the C chain via CCDB, but for now, and to understand a little bit better how Avalanche works, is Avalanche is not one single chain in contrast to a lot of chains that are currently out there, but we also have multiple chains. So Avalanche allows you to launch your own chain in order to, and this is basically because we want to have horizontal scalability on top of being able to customize for every type of use case that can be benefited by having blockchain on top of that. So this is our current landscape of mainnet. We have these many chains right now live in mainnet. And the thing is that when we try to optimize, or when we launch a new chain, they are probably not coming with everything already integrated. Especially, for instance, Filecoin will need to do like a specific integration in those chains in order to bring those services into our own like a specific blockchain. So the thing that we are doing now is, in order to do not require for this third party to integrate, what Filecoin can do is, or anyone that wants to consume Filecoin data, what can do is, so Filecoin right now is integrated on the C chain, which is one of the main chains. Let me see if the chat. Okay. Yeah, so what we can do right now is that we can consume that data from any other L1, just requesting that to the C chain. And in order to do that, I will want to just like set the ground for how interoperability on Avalanche works. Because, I mean, when you try to communicate to chains, they communicate because they don't have like any sort of way to read from the other state. They need to have a message that they take that as a proof that something happened, and from there they can interpret that message. The thing is how you know that this message is not being altered, or that the message actually happened, or this something that is triggering the action actually happened. And that is in reality the challenge of cross-chain communication. How Avalanche solves this is very interesting, is that it makes all the validators to sign the message via VLS signatures, to aggregate the signatures and just have one single signature, aggregated signature, in order to do not keeping growing as much of the validator set can grow, but only have one single signature that is being wrapping up that message, ensuring that the message is being properly distributed, and we know that that message hasn't been changed. The question here is that what happens if someone wants to alter that signature, is that the destination chain needs to have a concept of what is the actual signature that the validator set is using. Other way, someone can take this message, just sign it with some random signature, and deliver that message as if it was signed by the source chain. And this is where a trick has, like how Avalanche solved this, is that it gives a notion of these signatures to the destination chain validator so they can verify the authenticity of that signature. And this is done via the P chain. The P chain, for those that are not familiar to the Avalanche architecture, the P chain is basically one specific type of chain where every validator in the network, it doesn't matter which chain they are validating, register their signatures. So it's not a data chain in terms of like transactions don't go through this chain, but only the signatures and identities of these validators are stored in this P chain. So it acts like basically like a common signature directory or registry where you can just validate who is signing with which key. And with that, it will allow you to basically reject, in this case, this transaction, and only take and accept as a transaction, as a valid transaction, those that are coming with the signature that you expect. So this, like, even though it's simple, it's super powerful because it allows you to not relay, or you don't need to trust the relayer, but only the signatures, and you're already communicating with that chain. So you assume that you are already trusting the chain that you are communicating, because otherwise, why would you want to communicate with that chain in the first place? So At the implementation level, and this is like something super easy to do, is that there are like two smart contracts, or one in the destination chain and one in the source chain. The source chain will send the message, and the destination chain will implement this teleporter receiver interface just to receive the message, and from there it can create logic on top of that to receive that message, interpret it, and execute the message. And the send message is just like super short way, just calling the teleporter messenger, which is a contract that is already deployed there, that like makes all the verification under the hood of the signatures and create the signing of all the signatures. That is like practically transparent to the developer. It's just like sending the send cross-chain message, or calling this send cross-chain message method into the teleporter messenger with the information of which chain ID you are trying to communicate, what is the contract that is going to interpret the message, and some fee information about how you are rewarding that relayer that will take the reward in exchange of sending the message within a specific required gas limit in the execution chain. So and then you of course need to have the message, which can be anything encoded as bytes. So because this is just bytes, you can basically send any type of data, including anything that you are consuming from Filecoin. So how this process would look like in order to consume Filecoin in any Avalanche L1 is that because this service is enabled on C chain only, we will need the L1 just saying like, hey, I need XYZ data stored in Filecoin. Then it will send the message with the send message from Teleporter. It will receive it the message will be received on C chain, and it will process that through the CCDB bridge with Filecoin, and then we'll send the answer, we'll consume that, and we'll receive that data, and then we'll send it back to the Avalanche L1 that requested that. So that is basically the flow, right? Like send request, receive request, handle the request. This handle request will use CCDB just to consume that Filecoin data. Everything will be traveling as bytes in these two types. So this is what we call the Filecoin wrapper, or just basically the wrapper, the ICM wrapper. ICM stands for interchain messaging wrapper around the Filecoin services that are already deployed on C-chain. And from there, it will be sending the data to Avalanche L1. So in that case, Filecoin does not need to integrate directly on each of the L1s that are out there, but will only need to do the wrapper, and each L1 can be can deploy this L1 requester, let's say, in their own Avalanche L1 in order to actually being able to consume that data. So that is basically how you do it. It's like very high level. We can get deeper. If you want to get deeper into how Avalanche cross-chain communication work, we have an Avalanche Academy course specifically talking about ICM, so you can get deeper into that, or just like reach out to me so we can like solve all these questions.
I would take the last few minutes to go a little bit why we're doing with Avalanche, and then why we start going from. Just give me 1 second to share the screen. The reason that we're talking about with Avalanche and now with Avalanche ICM is because we like trying to put a Filecoin storage to Avalanche, and once we're doing the process, we're noticing that like all the small contract we're working needs to be like designed as an upgradable and a scalable solution. And also the cross-chain clients need to be designed as a more scalable solution so be able to adopt into different bridging solution. Like Xala was the orange one. And we need to be able to adopt to, for example, now Avalanche ICM, because it needs to not just supporting the Avalanche C chain, but also the whole Avalanche wider ecosystem building on Avalanche C chain as a subnet. And that's the reason that we talking with Avalanche, and we had the first solution was like, okay, we can put this storage to Avalanche and make sure that all the builders from C chain can access Filecoin storage. And then we realized that, oh, there's a bigger community from Avalanche also requires that access. And that's why the ICM coming into picture. And we will build the extend CCDB to implement the wrapper. And that's taking the advantage of making the architecture more scalable, and we can do it easily. And so that's the plan. And in the future, like when the FWS is coming and CCDB is also going to be integrated into that, and then making sure another good side of making it modular and scalable is we can also support different storage process as well, like completely on-chain storage and maybe directly data onboarding and then PDB. All this can be easily just integrated into CCDB as well. And also the on-chain payment is something that we're going to implement right now after the FWS is ready. And I think time is running over. I will just show the code very quickly. And we have, based on what Zen has built as on-ramp contract, we built it into a separate part. The first is on-ramp contract. It has all the contract we need to take to deploy the Filecoin or other chain. And it's designed as a solution that you can just easily, if you go into a few steps, you can deploy to any chain as you want. And then the same as the cross-chain clients. It's a standalone application, and like we can easily extend it to other chain, and then making sure that cross-chain clients will be listening and processing the data come from different chain. And in the future, we also want it to be a plugin solution that can welcome other people to run it. For example, all the storage on-ramp, they can come in to run a cross-chain client, and then processing the data coming from different chain, and then using that solution to store on Filecoin. And we built the little demo for the Avalanche with like very simple UI. So basically, this will just take a file, and we can just upload any file from. I have to make a cat photo, so just for this event. And so we can upload a file and save in the buffer. The buffer can be IPFS or can be your cross-chain client's buffer. And then also attach a payment. Currently, it's the payment on Avalanche, because we don't want people stored it on Avalanche has to deal with token on Filecoin, so they can pay directly with token on Avalanche. And then on the C chain, the Fiji testnet, the ESDC is supported. So that's just the process of you pay a token, and then the token will be held in the on-ramp contract, and then that token will be released to the people who process that data. It could be a storage provider. It could be someone is running cross-chain clients to process that data. And I mean, it's the process is basically you have to approve that token to be able to transfer directly in the on-ramp contract. And so once it's approved, you can start storing data on Filecoin. And this will interact with on-chain contract deployed on Avalanche. And eventually those will be wrapped around with ICM and then be able to deploy to the other Avalanche L1. And once it's done, I'm going to skipping making sure that like going fast because it takes some time. So once it's done, and then the deal will go to the Filecoin, and we'll be able to find the deal coming to the Filecoin. And then once the deal landed on Filecoin, you'll be able to look at on the blockchain explorer. If you have a node, you can check on the node. And after that, all the proof will go sending back to Avalanche. And now we're using Acceler. And just give me 1 second. So that was the cross-chain clients who's processing the data. And that's the clients, which is the prover contract on Filecoin. It's sending the proof back to Avalanche. And if you use that contract, looking at the Acceler, test Acceler, and you can find all the transaction, all the proof are sending back to Avalanche from Filecoin using Acceler. And it traces all the executions of sending the proof and the execution on the Avalanche and releasing the payment on the Avalanche to with the payment that we just paid with USDC. And I think that's just a simple demo of like now on the Avalanche, we can already store data, and those are built with on-ramp and with cross-chain clients, and eventually contain to the SDK that built it on Avalanche C-chain can just integrate it into the front end, storing data with the payment. Also be able to verify if it's stored on Filecoin. We just make a little fake border here that you can also verify and test it's safe stored on Filecoin. And in the future, like we are also going to implement the ICM wrapper, and hopefully we can get more and more ecosystem coming into Filecoin and we can store more Web3 data on Filecoin attached with on-chain payment. Was like that's what we're aiming to do with CCDB, and Avalanche is absolutely a great partner to start working with. All right, thank you guys. Sorry about the Wi-Fi and sorry about running a little bit over. I hope you guys have fun listening all the talk about FWS and PDP, and it's something that I'm excited about.